Today we shall discuss about queue data structures. Mainly we will focus how a queue structure can be programmed. Now, programming is an important what is called the activity for any data structure actually. This is because to earn the skill in any programming, you have to exercise two things. One is algorithm and data structure. So, logic behind any programming better can be exercised if we try to implement an algorithm using a data structure. So, this is why we give emphasis on programming. Queue is also no exception. In the last video lectures, we have learned about queue data structures in details. So, this is basically theoretical point of view. Now, today there is a practical point of view, and this discussion will continue in the next lectures as well as, but in the next lecture we will try to understand the Java utility support in the form of Java collection framework, so that queue can be utilized in your program. So, let us start today's topic. Today mainly we will discuss about how a queue can be maintained. So far the maintenance of queue data structure is concerned, there are two ways usually a programmer can think for. One is using an array. So, using an array, how a queue structure can be represented. Then we have also learned about linked list. So, here is an application of the linked list, so that a queue data structure can be implemented. So, two representations, namely array based and linked list based for the queues data structure. And learning a data structure can be complete if we see how actually a data structure is applicable to solve some problem. So, today we will discuss using linked list representation of queue data structure for an application called CPU process scheduling, which is basically very important application usually followed in any operating system implementation. So, now let us come to the discussion of implementation of queue data structure using array. Now, like any data structure programming, here also we will exercise a generic implementation of queue. Now, let us see how a queue data structure can be implemented using the generic concept. So, first of all we have to define a generic class. Now, in this program, as you can see, we define a generic class. The name of the class as we have given here, queue A stands for array representation. So, it is basically queue using array, and here you see it has a generic type T. This means that this queue that we are going to define can hold any type of data, integer, it can be character, string, even the user defined data type like this. Anyway, essentially a queue is basically a storage space. So, we have to define an array to store the elements for in the queue. So, here we define the array, the name of the array where the elements will be stored is data, and it is basically of type T. T can be anything, as I have already told. Now, a queue is characterized with two pointers, the front and rear. So, we define the two pointers as integer because they are basically indexing. And here I want to mention one thing. So, this is basically is an array of finite size, and in this implementation we will assume that the index starts from 0 to say some number n minus 1. So, this is basically index. So, this means that the front and rear will move from 0 to n minus 1. However, in order to mention that q is empty at any instant, what actually we will see is that the front equals to 0 and rear equals to minus 1. Now, here I am telling you why the two pointers front and rear. I can say like this, as you know, q is basically is a first in first out data structures. So, there are two pointers rear. So, let it be r, r stands for rear, and another pointer let it be front, f. So, here basically insertion and deletion should be at two different ends. So, the element next where it needs to be inserted, it basically at r. So, if the next element comes, the next element will be added where exactly r points to the next one. So, this basically is the next location for the next element to be added into the queue. So, next to r. On the other hand, if we want to delete an element from the queue, it should be deleted exactly from the location f, f is the front pointer. Now, so before insertion an element, so r needs to be incremented by 1, and again after the deletion of an element from the queue, the f will be incremented by 1, and you can say both r pointers and f pointers move from this direction to this direction. So, a queue will be treated as empty queue if we say front equals to 0, that means it is here, that means q is ready to remove an element from here, and rear equals to minus 1. So, rear is basically here. So, this is basically a check that we can think for to understand whether a queue is empty or not. Now, we can say a queue is full if we say r reaches to here. If r reaches to here and next time if new elements come for inserting into it, then we can say that queue is full, overflow. Now, again as the front and rear moving this direction, so sometimes r is here, queue is full and front remove all elements and come here, then at that point what we can say, after removing this front will be increased by 1. So, that means front equals to n. So, if we say that front equals to n, then again we can reset this front and rear as 0 and minus 1 respectively to indicate that queue is now empty, and again we can repeat the procedure. So, this is the logic that we should follow, and accordingly we can implement the different methods, the methods namely NQ and DQ, in order to maintain, in order to perform the insertion and deletion of elements from the queue. So, with this consideration, we initially define a queue passing an array, assuming that A is an array passed. So, we can load this queue with an array of elements. This A array of elements may be null also. In that case, this data will be null, nothing. Whatever be, if you do it accordingly, we can write that front and rear is basically 0 and minus 1 respectively to indicate that at the moment queue is initially empty, and A dot length, if A is empty, so it is basically null. Okay, so this is the constructor that is there in the generic class declaration, and we have to add methods in order to make the class declaration complete. So, the methods those are required is NQ, DQ, is empty and print queue. NQ is for inserting an element into a queue, DQ is for deleting an element from queue, isEmpty to check whether queue is empty or not, and print queue is basically to print the current elements those are there in the queue. So, these are the 4 methods that we are to add one by one. So, let us start first NQ operation. We will implement each operation one at a time and write a master program to check whether the operation is working or not, and then we will add one next method and so on so on. So, let us start defining the NQ operation first. Now, here NQ operation is very simple. Here I have defined one operation for you. You can check this operation, you can copy this code, run in your machine, and you can try to see how it is working. I will come to how the operation can be tested by writing a master program here. So, this is basically NQ, as I told you, insertion, and so far the insertion is concerned, it should be added some element at the rear actually. So, that is why here you see if rear is greater than length minus 1. So, that means if rear goes to at the end, then we can say that queue is overflow, no more insertion is possible. So, NQ will fail. If it is not like that, then what we should do, that we should increment the rear pointer, that means go to the next one, and then we can add the elements which needs to be added there, A supposed to be added into the queue there. So, this way it will complete the insertion operation, and you can check all these methods is valid even if the queue is empty, and queue is full, that is also checked, and if queue is not full, this will do it. So, in all situations this method, if you can call for a queue, it will work, I hope. So, you can verify it. So, this is the NQ operation. Now, let us come to the next, the DQ operation. Here is the DQ operation that we have defined. DQ operation does not require any argument to be passed, unlike NQ operation. However, DQ operation should return a value, is basic value of the type that basically Q stores. So, T. Now, here you see, so the first check that okay fine, T we define X is a temporary, actually if it deletes an element, then it should return that element. So, X is basically the elements to be returned. So, initially X is null, means it does not return anything actually in that sense. So, null. Now, before going to check the deletion operation DQ, we have to check first that if it is empty, because if a queue is empty, then we do not have to perform any operation, DQ operation. DQ operation is not valid for an empty queue. So, we just simply return null. If it is not empty, then we have to perform this operation. Now, you see what we are doing here, as I told you. So, deletion will take place from the front one, and this way first in first out will be implemented. So, here at the frontmost element will be copied into X, this means X needs to be returned, and then front will be incremented to the next location and we return X. So, this is a pretty simple the operation that we can think for the DQ. So, this operation is basically the DQ operation using the array representation, and as you have already told you, if even it is the queue is full, that you can check that this method is also still valid. So, you have to test the operation under 3 different situations: empty, it is just or not empty, and it is full, and you can check it anyway. So, we will definitely check it. Now, here you can see we have used one isEmpty method. We have not declared isEmpty method earlier, but anyway we will go for declaring isEmpty method. Now, let us declare isEmpty method. It is very simple again. So, isEmpty method will return true or false. So, that is why return type is boolean. Now, here we are checking whether a queue is empty or not, and this is the condition that basically stands for indicating queue is empty. The condition is that if front greater than rear. So, whenever the front exceeds the rear pointers, then it basically check that it means that queue is empty. So, it is return true, otherwise it return false. So, this is a pretty simple method and the condition needs to be followed like this one, and that is all. So, this basically implement 3 methods, and then another method that is remaining, this is basically the print queue. Print queue is pretty simple. At any instant, whatever the elements in between front and rear we need to print. So, the method is again very pretty simple. It is here the print queue method as we have defined. It does not require to return anything. So, return type is void and it does not require any argument to work with. So, it is null void. And now, if not empty, definitely there is no point of printing elements for an empty queue. So, that is why we have to perform a check. If it is not empty, then only for int I equals to front and I less than equals to rear. So, basically all elements in between front and rear including both including both are basically the elements in the queue at any moment. So, we just simply go on printing those elements from the queue, and finally, we come to the end. So, this is basically the print queue method, pretty simple, and this completes all 4 methods declaration for the array implementation, implementation of queue using array. Now we are in a position to test the data structure that we have implemented, a generic data structure of queue implemented using R. So, for this purpose we have to write a master program. The master program should include enqueue, dequeue, isEmpty, print stack, whatever be the order you wish, and you can check. So, this way you will be able to test for an empty queue, for non-empty queue and full queue, and performing the operations there. Now, here is the master program that I have given an idea for you, but you can use the program, but you can add any order regarding the in any order you can perform insertion, deletion into the queue. Now, you see this program is basically QA implementation demo, and here we declare array. Array is basically array of integers, type it is declared. Initially the size is 2, we have intentionally made the size 2, you can make it little bit larger size anyway. So, no issue, it is there. Then what we do is here this is the QA, our array implementation for the queue, and here we are passing the generic type that integer, that means we want to store integer value into the queue, and this is here you see we initialize the queue passing array. Array is basically our elements. So, initially this array is null because it is just allocated. So, there is no element at the moment. So, it is basically empty array we can say, because this array is declared, but not initialized by any elements. So, it is like this. So, this basically you can check is basically call the constructors as we have defined there in the queue implementation in our class declaration, and basically call the constructor and queue. This is basically our queue actually object. This is the queue actually, right, and this queue is ready to allow a programmer to insert and delete and print, isEmpty, test, everything. Now, here we are performing certain operation as you see queue.enqueue1. So, basically enqueue method we are calling here, passing an argument 1, that means we are inserting the first element into the queue which is 1, and after inserting we are just simply print queue. Next we are inserting another element and print queue, and so on so on. Now, here up to this it is okay, no problem, but you note that our size of the array is 2. So, whenever we come here, then we can see the queue is full because it is already full. So, print queue will print only 1 and 2, but it will not insert any element into the queue. Now, let us dequeue. So, this dequeue is valid, again this DQ is also valid. Again if you come to this DQ, then here again you will see this is not a valid. This is because in this case Q is already empty. So, here the two cases are not valid because this is full and this is empty, and all other cases this is basically non empty situation. So, this way we have written the master program so that you can test all situations. Now, you can again rerun the program by changing these two as a little bit larger, maybe 5, 6, 10, and then performing several operations. If possible, you can write a for loop and do many insertion, then many deletion and so on, and you can check it. So, programming that you can continue with this what is called the master program and the declaration that we have defined for the Q using array to test your programming skill. So, this is must actually, otherwise you will not be able to cope with the programming and particularly data structures and algorithm in order to implement your program. So, this is important. So, this is the case that we have discussed about Q implementation using array. Now, we will repeat the same thing, but using another data structure, namely linked list. Now, as you see, using array, if we implement a Q, then it is limited to the size of the array. So, this is one basically the disadvantage for this method, otherwise it is very fast actually. So, if you implement a Q using array, it is really very fast, but only limited that it is size is limited, static or bounded like. On the other hand, if you use linked list, because linked list can allow you to add as many as elements you wish, that means that it is unbounded or virtually it is infinite capacity or it can grow dynamically. That is why the linked list is more preferable, and you will see the Java collection framework basically follow linked list implementation for their queue, not that array, but array queue has many other significance, particularly speed point of view. Anyway, let us come to the discussion of our next task is basically implementation of queue using linked list. Now, like the array implementation, here also we should declare a queue structure using linked list, and that is also generic. So, a generic what is called the class needs to be declared first with the fields and the constructor. This is the usual procedure, and then different method related to NQ, DQ and everything. Now, let us proceed. Now, so here we can tell one thing, linked list needs to be used here. So, we should have the linked list implementation first. Now, already we have discussed about how the linked list can be defined for the program is with us. So, that programming, that all the class declaration for the linked list should be imported in this program. So, here assuming that this class is defined in this package, so we should import this package first. So, this means that all the previous programming for linked list is now added into this program. And as you know, in this package the class JLinkList is defined, that is also defined generically. So, what we are doing is basically we are creating two pointer, the front and rear of type JLinkList. So, this basically pointer to indicate that they will point to two nodes, the front and rear. Now, in case of Q, as I already told you and we have already exercised for the array, is that two pointers front and rear. The rear is the position where the deletion will take place and front is the position where insertion will take place. So, rear is basically at the end of the queue or end of the queue we can say. So, in this means that the insertion will take place at the end, and front is basically front or just next to the head. So, deletion will take place from front. Anyway, so we just declare a constructor for this class QL. This is basically the constructor to initialize a linked list, that basically actually a queue for you. So, here we just initialized linked list constructor, initially it is empty, and front is basically is the frontmost location, it is basically you can say header. So, this basically creates front and then front, and rear is equals to front. Initially rear and front are the same, it is a header. Header indicates that initially queue is empty with the linked list implementation. Now, so we are now ready, the queue is declared. Our next task is basically to add method into this class declaration. So, in this position we will include the declaration or definition of the method, the enqueue, dequeue, is empty, printqueue one by one. So, if we do it, our task will be complete. So, let us see how we can add the method one by one. So, this is basically the enqueue method. It is very simple, enqueue, and it does not return anything. So, void, and we have to pass the element to be added here, and this is very simple. As you see, enqueue operation is nothing but insert at end. So, insert end is basically defined for the linked list implementation, that is all. So, it is basically we just insert an element at the node rear actually, that is fine. So, this basically will complete the insertion. Likewise, the dequeue operation, is basically, here you note one thing, need not to, for the enqueue operation we do not require to check whether queue is full or not, because queue will never full so far the linked list implementation is concerned. But for the dequeue operation we have to check whether the queue is empty or not. Queue is empty means when we can say that linked list is empty actually. So, there is a test is required. So, this test is here to check that if empty or not. Again, if empty method we can define for the linked list, is very easy, and if it is not empty, and then if it is empty, then definitely we will print that this linked list is empty or underflow. If it is not empty, then we see delete front, that means the front, this method is defined for the linked list class. We can call the delete front operation at the front pointer, that means in the front. So, it will delete this element node, and that is all. So, it deletes and definitely return, here we can write return the element. So, delete front itself return the value. So, this way it will return automatically. So, this basically completes the dequeue operation for you, and so this is the dequeue operation. Now, let us come to the is empty operation. Is empty operation is pretty simple. It basically is a for is empty. This method is again defined for the linked list class that we are using. So, simply call this method to check if it is empty, then true, else it is false. So, this method is very simple here, and you can see the method is simple because we have already linked list implementation, and we are just using this linked list implementation for our queue, and that is also one application of linked list actually. We have also experienced the application of linked list to implement our stack also. Anyway, so this basically complete, and finally the print method is same as the printing the linked list, and okay, obviously the print method you have to check if it is empty. If it is empty, nothing to print. If it is not empty, print list method. This method again defined for the linked list class. So, call the method and it is done for you. So, these are the programming what is called the looks that you should have in order to implement the queue structures, and accordingly it implies. So, we have done all 4 methods and added one by one into the QL, that is the generic class implementation for the queue structure in this case using linked list, and now we are ready to have a master program. So, here is the master program, and here we can see, here we are declaring a queue, that is basically it is our queue using QL basically our class declaration, and this is an integer, that means we want to store integer into this one, and this completes your declaration about a queue. Queue is ready, and we can perform like earlier the different insertion and deletion in any order. So, we have find this order and everything, and you can check that here actually we have to test whether is empty. So, if you Q1, Q2, then NQ, so 3 elements are added, and then perform DQ, it is okay, this is also okay, this is also okay. So, it is there, but later on if you perform any other DQ operation here, in this case for example, you can check it and you will see that it is it can gives you underflow, that means Q is empty error. Anyway, so you can check with different situation, you can bring to this program, and then you can test that your program is working, and this basically completes the linked list queue implementation using linked list. So, we have learned about two ways, array implementation and linked list, and quickly we will cover one application of queue. I just want to discuss one application. It is basically process scheduling. So, here idea is that many process will come and you have to serve the process. Now, here the policy that needs to be followed is that the first come first served. That means the process which come first needs to be served first. Now, if it is like this, then we have to follow a queue structure to maintain this policy. So, it is basically called FCFS, first come first served process scheduling, and to implement this scheduling protocol we have to follow one queue. Now, again let us consider the linked list implementation of the queue to implement it this one. Now, before going to use the queue, first let us define a process. We can define a process by its an identity and what amount of time that it requires. So, here with this consideration, a process is a class we declare here. Index is basically ID of the process, time basically how much time it require, and this constructor is basically initialize a process and it will basically print what exactly the process it is. So, it is the process. So, this is a pretty simple to define a process. Now, you can use this class declaration to define a number of processes, create process instances, and then we can add process whenever they are created into array and then implement into the FCFS policy. So, the next part is basically the queue, and process will arrive into the queue and then add them into the queue and then serve them. So, here is the next part of the program. This is basically queue application demo. Here you can see we can create 4 processes. So, it is basically these are the 4 processes and it basically indicate their identity. These are the 4 process identities and this is the time that is required in order to serve the process, 5 unit, 15 unit like this one. And we use one temporary variable, it is called the done. Total time actually after this policy, that means all processes are served, then how much time the scheduler takes to calculate. Initially it is 0. Now, here we maintain a queue, this queue is FCFS, let it be, and here we use the QL, that is the linked list implementation of the queue, and it is basically process because we want to store process into our queue. So, you can see this is a generic thing, so that process can be added into the queue, not like integer or string that we have discussed earlier. Now, all the process have arrived. So, we can insert or enqueue the process into the queue. So, we are entering all the process into the queue, but here we have given an idea, but you can see one process can come after this one, or you can remove this process or whatever it is there, that you can go on. Initially the process arrives there and the process will be served as a first come, then arrive one will be first and so on. Now, so this is basically job comes to the scheduler and now scheduler has to serve the processes. Now, here is the next part of the program that we can think for, and this is basically how the process will be served. As you can see, so this basically dequeue because it is basically serving. Serving is basically by means of dequeue implementation. Dequeue implement that it is serving done and then total time that is required for the scheduler to serve this process. So, this way all processes are served one by one because in the same order it will basically serve. Dequeue will follow in the same order as enqueue takes place and then finally it will print the how much time the scheduler takes to serve all the processes. Now, this program again you can customize according to the different way. In between some enqueue operation can be carried out and then you can check it and you can test it and many more dequeue operation and so on, and you can understand. And also you can print queue at any instant and whatever is empty you can check, whatever you can do. So, here you can see queue FCFS is the queue which basically helps you to implement your problem or your application or program. So, this is the processes, this is one application that we have discussed. There are many more applications you can find and this is the link. You can find many more applications with details discussion about, so that you can test your programming skill to solve each application if time permits. More programming definitely will gives more skill and more confidence in your programming endeavor. and this is the link that again we have maintained all the concept that we have covered in this video, as well all programs that we have used here for the demonstration. So, with these things I would like to stop here for today. Next we will discuss about implementation of queue using Java collection framework. That is another interesting topics that is waiting. Thank you for your attention.